Hi everyone, we're going to go over ACT Review Packet 6, Exponents, Matrices, and Vectors. Um, there's some interesting topics here. This material is covered on a smaller portion of the AP test. We should probably be comfortable with exponents and matrices at this point, but there are still some questions here that bear some consideration. So let's start with those first perform questions, number 17. And number 17 says, which of the following is not a real number? Well, I know that that's negative 3, and I know that 3 to the negative 2 is 1 over 9. But square root of negative 9 is 3i. That is not a real number, so we have C for number 17. 18. 18 says the value of x plus m over n is an integer. Remember, integer. Think whole number, but could be negative. No fractions, no decimals. When m equals 2 and n equals 3. So we've got x plus 2 over 3. The result is an integer. What is a possible value of x? Well, if I think about an integer, that means it can't be a fraction, which means it has to be divisible by 3. So I'm thinking of a number that's divisible by 3, and that's after I've added 2 to that. I'm sorry, I add 2 to a number, and then I divide it evenly by 3. So I'm looking for a number that's divisible by 3 when I add 2 to it. So 3 times a number is x plus 2. X equals 3 times a number minus 2. Yeah, no, that's not helping. So I guess what I'm looking at here then is, why don't I try these examples? And this is a strategy that I used a couple of times in this packet. If I try negative 1, negative 1 plus 2 divided by 3, is that a whole number? I mean an integer? No. What if I try 0? Well, 0 plus 2 over 3, that's just 2/3. That's not an integer. If I plug in a 4, 4 plus 2 is 6. 6 divided by 3 is 2. That is an integer. So sometimes just plugging in the choices will be the easiest strategy. 19. We know that the definition of I is the square root of negative 1. And we know, therefore, that I squared is negative 1. So then they ask us I to the third plus 4i over square root of negative 9. What's that? Well, we should know that I to the third is I times I squared, or negative I, because negative 1 times I. So I've got negative I plus 4i on top. On the bottom, we already talked about the square root of negative 9 in problem 17, and that was 3i. I combine like terms on top, there's the bottom, and I end up with 1. And 1 is choice B, B for 19. And then number 20, we've got the product of the matrix, and we're looking for the values of x plus y. So I need to find this box, top left, top row, first column, so I multiply the top row, 1, 2, by the first column, negative 1, negative 3, and I get 1 times negative 1 plus 2 times negative 3, which is negative 7. And I need to know what y is, and y is in this box. That's also in the top row, but it's the second column. So I'll be using 1, 2, and I'll be using negative 2, negative 4. 1 times negative 2 plus 2 times negative 4 gives me negative 10. We're adding x and y together, and so I get negative 17, which corresponds to F. F for number 20. Okay, so let's start the on your own. There are only 20 problems here. 1. Which of the following is equivalent to this? Well, this is a calculator portion, but these are really big numbers. And I don't think I'd recommend using a calculator on this. Instead, I notice that, well, let's take a look at this. If I had x to the third minus x squared, I could factor out the smallest power of the common factor. I would subtract that 2 from here to get x to the 1, and x squared divided by x squared is 1. Well, I'm going to use a similar factoring strategy on 7 to the 77th minus 7 to the 76th. I'm going to take out the smallest factor, 7 raised to the 76th. What's left over when I do that? Well, 7 to the 77th divided by 7 to the 76th, I subtract the exponents. I get 7 to the 1, or 7. And here, when I divide 7 to the 76th by 7 to the 76th, I get 1. So this is just 6 times 7 to the 76. And that's choice E. Choice E for number 1. 2. X over 2 minus x over 6 is an integer. Well, if x over 2 minus x over 6 is an integer, let's make a common denominator and see what we can say about x. So I multiply by 3 over 3 here, and I get 3x minus x over 6, or 2x over 6, which reduces to x over 3. Well, this number is divisible by 3. Which means that x must be some multiple of 3 if the result of dividing it by 3 is an integer. Remember, an integer, no decimals, no fractions. So this has to be a number like 6 or 9 or 12 or 15 or 18, and that means that x is a multiple of 3. So my answer here is J. Number 3. What is the value of negative 2 to the negative third plus negative 3 to the negative second? Well, raised to the negative third means I have negative 2 to the positive third on the bottom. And raised to the negative second means I have negative 3 to the positive second on the bottom. Negative 2 times negative 2 times negative 2 is negative 1/8. And negative 3 times negative 3 is positive 1/9. If I make a common denominator here, say 70 seconds, I have negative 9 plus 8 over 72, which reduces to negative 1 over 72, and that's why B is the answer to number 3. B is the answer to 3. 4. What is the value of 9 to the negative 3/2? Well, I know that this is the same as 3 squared to the negative 3/2. And when I raise a power to a power, I multiply those powers. And so this becomes 3 to the negative 3, which is 1 over 3 to the third, or 1 over 27, which is why J is my answer for number 4. 5. Given which of the following is equivalent to the square root of 0.0016x squared? Well, we know the square root of x squared is x. And the square root of 0.0016, well, that's the square root of 16, which is 4, times the square root of 10,000, which is 100. So I've got, oops, point 0.01 times 4 times x, or 0.04x. Of course, you could always do this part on your calculator. We end up here with choice B. Number 6. Complex number, what's the value of 2i minus 3 squared. Well, that's 2i minus 3 times 2i minus 3. 2i times 2i is 4i squared. Minus 3 times 2i is minus 6i. Minus 3 times 2i is minus 6i. And minus 3 times minus 3 is plus 9. Remember, I squared is negative 1. Negative 1 times 4 is negative 4. And I can combine my like terms here and get negative 12i plus 9. 9 minus 4 is 5. Minus 12i means my answer for number 6 is K. K is the answer to number 6. Seven. I is the square root of negative 1, which has the greatest value. Well, remember, I squared is negative 1. I to the third is negative I. I to the fourth is 1. And we had talked about how you could take a different exponent, and you could take that exponent on I and divide it by 4, and you could look at the remainder. And we said when the remainder was 0, that meant that this expression was equal to 1. Well, when I look at these choices, I notice that not all of them are divisible by 4 evenly. The only one where both exponents are divisible by 4 is choice D. I to the 16th, that's divisible by 4, so that's 1. And I to the 12th, that's also divisible by 4 evenly, so the remainder is 0, so that's also 1. And therefore, the value of these two terms added together is 2. All the others have a value of 0. I don't see any with negative 2, do I? No. I see a 0, a 0, a 0, and a 0. So 2 is definitely bigger than 0. D for number 7. 8. So we're looking for the value of z, and in order to find the value of z in this situation, x, 6, 13x plus 2, 3y, 5y equals 6, 12, 18z. Since this is just an addition problem, all I need to do to find this is add things that are in the same corresponding location, but those things are x and y, and I don't know what they are either. So I look up here and I notice, oh, here's an x in the top left cell. So I'm going to add top left cell with top left cell to make top left cell. X plus 2 equals 6, so x equals 4. Now let's repeat the same process with y. I see y here in the top right cell. So I'm going to take top right cell plus top right cell equals top right cell. So I get 6 plus 3y equals 12. When I solve this equation, I'll start by subtracting 6 from both sides, and I'll get 3y equals 6, or y equals 2. So remember, z was equal to x plus y. So z equals 6, and that's why my answer here is G. G for number 8. Number 9. What is the product? Well, first let's check if we can do this. This is a 1 by 3 times a 3 by 1. Oh, we can do that. These numbers are the same, so we know we can multiply. And this is the size of my product, a 1 by 1. So all I'm going to be doing is multiplying the row 1, 2, 3 times the column negative 1 times negative 2 times negative 3. So this times this plus this times this plus this times this. And so I end up with negative 14, or choice A. Choice A for number 9. Okay, let's take a look at 10. 10 says if the vector u is given as 25, 30, what would negative 2/5 of 25, 30, b. Well, if I distribute that negative 2/5 times 25, these cancel, giving me negative 10. And if I distribute the negative 2/5 times the 30, I can cancel and get negative 12. Sorry, copied the problem wrong. There was a negative there already, so negative times negative makes positive. So my result should be negative 10, positive 12, which corresponds to choice G. G for number 10. Number 11. What is the greatest integer smaller than the square root of 250? Well, you just have to put that in your calculator to figure out that this is going to be 15 point something. I know that 256's square root is 16. And I know that square root of 225 is 15. And so square root of 250 must be in between those. So the next integer smaller than this one would be 15. Smaller than this would be 15. And that's choice A for number 11. What about number 12? Well, if I do 4 11ths in my calculator, I get 0.363636 repeating forever. So I know every 2 digits this repeats back again. So if I divide 100 by the length of my repeating pattern 2, it goes in 50. 50 times, goes in evenly. So evenly means there's no remainder, so I wouldn't be counting to the next one. It would just be this. Here, for example, if I divided in once, I would get one group of 2, and that would, yeah, I'm not going to try that. I recant my statement. So I'm going to divide when the remainder is 0. That means I'm not going to count any additional digits over. So I'm just going to know that 6 is the value of the 100th. And that corresponds with J. J for number 12. Okay, let's take a look at 13. 13 says 3 times 10 to the 4th times 8 times 10 to the 9th over 1.2 times 10 to the 6th. Well, I like taking care of this in pieces. I take care of all these 10 to these first. And I know when I'm multiplying and the bases are the same, I can add the exponents. So on top, I have 10 to the 13th. On the bottom, 10 to the 6th. When I'm dividing and the bases are the same, I can subtract the exponents and get 10 to the 7th. So my answer is going to have a 10 to the 7th in it. Or is it? So let's take now these values. 3 times 8 is 24 on top, divided by 1.2. And all of that is times 10 to the 7th. Well, 24 divided by 1.2 is 20 times 10 to the 7th. But this isn't in scientific notation. I need to move the decimal place over 1, which means I need to multiply over here by another 10, which means that instead of 10 to the 7th times 20, I'm going to have 2.0 times 10 to the 8th. 2.0 times 10 to the 8th is choice C for number 13. 13 is C. 14. What is the product of square root of 8 plus 6 and square root of 8 minus square root of 6? Well, square root of 8 times square root of 8 is square root of 64, which is 8. And square root of 8 times square root of 6 is negative square root of 48. And then we have a positive square root of 6 times a positive square root of 8, which is positive root 48. Notice that these middle terms are going to cancel. And then we've got a positive times a negative for a negative. Root 6 times root 6 is the square root of 36, which is 6. So since these cancel, I end up with 8 minus 6, or 2, and that corresponds to choice G. G for number 14. 15. We've got 5 root 3 squared. Well, there's no plus or minus sign here, so I can apply this exponent. 5 squared, root 3 squared. Well, 5 squared is 25, and root 3 squared is root 3 times root 3, or the square root of 9, and the square root of 9 is not 9, Mr. Kukla, it is 3. And so I get a value of 75 here, which is why E is my choice for number 15. 16 says x is greater than 1. Which of the following must be true? Well, I notice a lot of these problems have square root of x in them. So I'm not going to choose an x value like x equals 2 because I don't feel comfortable with square root of 2. I want to pick a number that's bigger than 1 that I can take the square root of. And for me, that's x equal to 4. If I make x equal to 4, I know how to take its square root, and so I can do some comparisons. So I'm going to take this x equal 4 and plug it into my different choices. Square root of 4 over 4 minus 1, is that less than 0? Well, that's 2 over 4 minus 1, which is 1/2 minus 1. Well, that is less than 0. So I'm not going to go any further checking the others, but I did, and no, they don't work with 4. And so E is my answer for number 16. Number 16, the answer is E. E for 16. And this is one of those where I picked a value and plugged it in. I would have plugged it in for the others if I didn't find it in the first one. 17. X to the 4th equals 90. Well, I could do the 4th root of both sides, and on my calculator I could do 90 to the 1/4 power to figure out a decimal approximation for this. But the way I did it was to say, well, I know that 3 to the 4th is 81, and 4 to the 4th is 256, and I know that 90 is between 81 and 256. So what integers does this have to be between? This x value has to be between 3 and 4, and so my choice is A for number 17. Okay, 18. 18, they'd say, what is the square root of 8 minus 6i? Square root of 8 minus 6i. Well, this requires de Moivre's theorem, and if we were in honors pre-cal trig, I would have taught you de Moivre's theorem. But we're not. We're in regular pre-cal. And so my recommendation here is that you start with the first one, 3 plus I, and square it. And so I get 9 plus 3i plus 3i plus I squared. Well, here I have a positive 6i, and here I have 9 minus 1, or 8. Well, they want me to get 8 minus 6i, and I got 8 plus 6i. So what if I try, that means F doesn't work. What about G? 3 minus I, 3 minus I. And so we get 9, and we get minus 3i, and minus 3i, and minus a minus is plus I squared. And lo and behold, we get our 9 minus 6i minus 1, or 8 minus 6i. Trust me, this is a lot easier than de Moivre's theorem. So we're going with just squaring the given options until we find one that works for us, and that means G is the answer for number 18. 19. 19 says, given these matrices, what is the head of recruitment's estimate for the number of employees who will leave within the next year? So they give us the number of employees in each department, and then they give us probabilities of them leaving. So we know of the 300 people in marketing, 13% will leave likely, and of the 200 people in PR, 15% of them will leave, and of the 600 people in development, 12% of them will leave, and of the 100 people in recruitment, 14% of them will leave. And so 300 times 0.13 is 39. 200 times 15% is 30. 600 times 12% is 72. And 100 times 14% is 14. And when I add these numbers up, I get 69 plus 72 is 141 plus 14, or 155. So my choice here is B for 19. Our last question, number 20. Number 20 says U is to 0 and V is 0, -2. What's the sum? Well, to find the sum, as we'll learn in Chapter 6, all we need to do is add these x components and these y components. So 2 -2 is the sum, and that's choice J. There you go. That's all to this packet. I hope it felt pretty comfortable, and I hope you're feeling ready for the practice ACT test we're going to have.